Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 3 from the Prelim 2024 Gauteng paper, your paper 1. So it says a tennis ball falls freely from rest from point A, which is 44 meters above the ground. The time taken to fall to the different positions B, C, and D is given in terms of T as shown below. Ignore all effects of friction. So we can see from point A to point B, it takes 2t seconds. Then from point B to C, it's t seconds. And then from C to D, it's 3t seconds. Right, then 3.1 says define the term free fall. Right, so that one should be easy peasy, 2 marks. So we say free fall is the motion upon which the only force acting on the object is the gravitational force. Right. So you have your 2 marks like that in the back. Right. So free fall is the motion upon which the only force acting on the object is the gravitational force. Now 3.2 says calculate the value of t. So to calculate the value of t, let's collect our data. So since this ball is being dropped downward, I will take down as positive. And then we know if I take down as positive, my acceleration becomes positive 9.8 meter per second square. And then I know as I'm taking down as positive, I must answer all these questions using down as positive. So your choice of direction in the first question that you use for calculation will affect the rest of the questions. So you can't choose down as positive in 3.2 and then change it to upward as positive in 3.3. You need to be consistent with your choice of direction. Right, so this is down is positive, our acceleration is positive, and then our v initially, note that this is this falls freely from rest. So that means that this tennis ball is dropped. So it has a velocity of 0 meters per second initially. And then the time, delta t, let's take it all the way from point A to point D. So we are looking at the rest of the motion here, all the motion. So that's 2t plus t plus 3t. All in all, this will give us 6t seconds. Right, 6t, not 60, 6t. Then what are we looking for? We are looking for the value of t, right? And then what else are we given? If we are to look for the whole length of A to D, our delta y is 44 meters. And since we took downward as positive in our object, the tennis ball is going downward, then our delta y remains positive like that. Now, it's a matter of looking into your equations of motion, right? So once you have collected your data, you have to look for an equation of motion that has all of this, right? So that's how you choose the correct formula. First, collect your data, and then your data will lead you to the correct formula, right? So do not go and pick the formula and then try to adjust your data. Collect your data first, and then go and choose the correct formula based on your data. So, okay, based on my data, the formula that corresponds to this is the one that says delta y is equals to vi delta t plus half, and then a delta t square, right? Okay, so my delta y is 44, and then my vi is 0. The delta t is 6t, and then plus half, and then a is 9.8, and then delta t square, I will have 6t, and then square that. Okay, so obviously this 0 multiplied by whatever number, this will give me 0. So I'll just punch this into the calculator, and then it's supposed to give me 176.4 t square. Right. Now, in order to solve this, I understand this will be t square is equals to 44 divided by 176.4. And then in order to get rid of the square there, I need to square both sides. And then this will give me 0.499 seconds. So I'm just rounding off to 3 decimal places. And then obviously, if you were to round off to 2, this would be 0.50 seconds, right? So, but then let's keep it this way, 0.499 seconds. Okay, so now that I have t, so that means I can now be able to get the time exactly it takes to move from point A to point B, because this will simply just be 2 multiplied by the t, and then I can get the time in between here because it's just a value, 0.499 seconds. And if I'm interested in the time between C to D, I can just simply say 3 multiplied by 0.499. Right, so which brings us to this point, 3.3. It says calculate the height of the ball at point C, right? At point C. Now you will then realize that at point C, this is from A to C, and then if we are to add 2t and t, this will give us a total of 3t, right? So in order to calculate the height there, again, we can collect our data and say our delta t is 3t, and then our acceleration still remains positive 9.8 meter per second square. And then our vi, remember, we're still taking it from point A, so it's still 0 meters per second. And then we are looking for our delta y, right? So again, the same formula, delta y is equals to vi delta t plus half a delta t square, right? But then our vi is 0, and then our delta t is 3t, but then remember we already have the value of t, that's 0.499 seconds. So I'm just going to substitute my delta t as 3 multiplied by 0.499, right? Because it's 3t. And then half a is 9.8, and then again here I will have 3 times 0.499, and then let's not forget to square that. Now you simply just punch all of this into your calculator, and then you will get 10.98 meters, right? But then remember, we are to calculate the height of the ball at point C. From the ground, above the ground. So note that this is the distance that the ball covers from A to C. But then if we want to calculate the distance above the ground to point C, then you do understand that we need to then say our height is the 44 meters here minus the displacement covered, right? Or the distance covered. So 44 minus 10.98, then we are going to get 33.02 meters. So this is the height of the ball above the ground at point C, right? So I hope it makes sense. Okay, so 4 marks like that. And then now we move to 3.4. It says if after the first bounce, the ball reaches point C. So the ball drops here, bounces at point D, and then jumps back to point C. Sketch the position time graph for the ball from the moment it is dropped until it reaches point C after the bounce. And then show the following on the graph. So this is where we'll get our marks. So we need to indicate the time values at point D and C before the bounce in terms of t. And then we need to indicate, so note that in terms of t, we are not supposed to show any values, then the heights at A and C, and then we must also take the ground as the 0 reference point. Okay, so position versus time. Let's start with our Cartesian plane. And then this is what happens. So this is the graph if you take up as positive, So if you take up as positive, your graph is supposed to look something like this. And then, okay, let me do this so that I can draw both. So this is for the ones that will have taken up as positive. Whoa. So simply you just show the trajectory of the ball. So the position versus time graph would have to be the most simplest to draw, because you just show what the ball does. So it's from a height of 44 meters, and then it drops all the way down to the ground. And then from the ground, it bounces back up to point C. And then we did calculate. So everything that you are going to substitute or put in your graph is something that you have already calculated. So remember, we did calculate the height at point C above the ground, which was 33.02. So that's your point C there. So we can indicate that this was point A, and then this was a point D, and then this is now back to point C, right? But then remember, we must show the time. So the time it takes from A all the way to D is 6t, right? So 6t. So let's just indicate that. So this is 6t. And then now bouncing back to that point there, we will get that in between here, because from point A all the way to point C here, remember this is still on point C, the time taken here was the 2t plus t, which was 3t. So the time taken to reach this point as it goes down here and then reaches point C at this point on its way down is 3t, right, as indicated by this. And then now the time it takes for it to hit the ground at point D is 6t. And then we must indicate this is time in seconds. And then here we have a position in meters. So note that this is for upward as positive, but then for someone who chose to draw the graph taking downward as positive, the graph obviously will be below the x-axis. So same shape, it's more like a reflection along the x-axis, and then bounce here, show the bounce, and then again we have our 6t here, and then 0. So this is 44, and then right here we have the 33.02, right? So because we are taking down as positive, we'll just leave our values to be positive like that. And then there we go. At this point here, we must also indicate at that point it's 3t, right? So this is for the ones that took down as positive. And then you indicate again, this is time in seconds. Label your graphs, guys. It is very important to label your graph, then position in meters. Okay, so that's it for 5 marks. That's what you were supposed to indicate there. So I hope all of this makes sense. And then that's all you were supposed to do to get that 15 marks in the bag. So if you made any mistakes, note there, and then make sure that next time it doesn't dribble you. But with all that being said, press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.